Source of affordable energy, the oil and gas industry has become one of the main weapons and vulnerabilities of world powers. Oil is the cause of military conflicts, the driving force in political crises, and the subject of speculations on world exchanges. Nevertheless, this resource is already living out its final decades for a number of reasons. First, oil reserves across the globe are limited. An extract from the BP Statistical Review of World Energy 2019 report indicates, if the consumption volume remains at 2018 levels, the world's proven oil reserves will last for 50 years. Due to a potential energy crisis, many nations hasten to gamble on natural gas as a possible alternative to oil. But this decision does not fundamentally change anything. Humanity would still depend on a fossil fuel source, which would ultimately lead to a new energy crisis. Secondly, the use of fossil fuels negatively affects our planet's climate. In 2017, a study was published in Anthropocene Review, which estimated the impact of human activity on climate change to be 170 times greater than the impact of astronomical and geophysical phenomena. Airplanes, cars, factories, oil refineries. They all lead to catastrophic emissions of carbon dioxide into the atmosphere. Global warming leads to rising sea levels, an increase in the area of deserts, an increase in the frequency of extreme weather events, the oxidation of oceans, the extinction of many animal species, the spread of tropical diseases, and massive human migrations. Climatologists talk about three scenarios: optimistic, realistic, and catastrophic. According to the optimistic scenario, global warming will be controlled, and by the end of the century, the increase in average annual temperatures will not exceed 2 degrees. Life will become a bit better in northern countries and much worse in some disadvantaged southern countries, but there will be no fundamental changes. According to the second scenario, the planet will warm by 3 to 5 degrees Celsius, which will lead to irreversible melting of glaciers and rising sea level. In this case, our political and geographical maps will most likely have to be redrawn several times. The third scenario is the most catastrophic and, fortunately, the most unlikely. If the average temperature rises 6 degrees or more, the whole world, except for the northernmost countries, will turn into one huge desert. This will entail unprecedented political instability and the mass extinction of humanity. The planet is 6 degrees away from destruction. To prevent the catastrophe, the world community signed the Paris Agreement in 2015, which aims to stop global warming by preventing the increase in global temperature by more than 2 degrees Celsius. One of the main points of the agreement is the transition from fossil fuels to alternative energy sources. There are two alternatives as the main green energy sources. The first one is the use of natural forces to generate electricity. This includes solar, wind, thermal, and tidal energy. However, these methods have significant disadvantages, the main ones being low efficiency and a dependence on natural conditions. These restrictions lead to increased costs, the risk of operating power plants, and, as a result, to high-cost energy output. For instance, the Ivanpah solar power plant is 4 times more expensive and generated much less electricity compared to gas power plants. However, progress does not stand still. Research aimed at reducing the cost of energy from alternative sources is well underway. There is another alternative, which is conceptually new but has great prospects: hydrogen energy. The theory is simple. Hydrogen is an element which forms only one byproduct during combustion: water. No harmful substances. The energy intensity of hydrogen is 2.4 times higher than natural gas and 4.1 times higher than coal, which makes hydrogen not only environmentally friendly, but also a competitive resource. However, it is not all as easy as it sounds. Hydrogen is scarcely found in its pure form in nature. It must be produced from other compounds. The main reagent for hydrogen production is fossil hydrocarbons, such as gas, oil, and coal. Modern hydrogen production comes with huge carbon dioxide emissions. For example, a little less than 10 kilograms of carbon dioxide are released into the atmosphere per kilogram of hydrogen produced from natural gas. Another source for hydrogen production is water. The method is based on electrolysis technology. However, this method involves a huge expenditure of energy which is generated using the same fossil fuels. And where there is a high cost of energy, there is a high cost of the final product. There are two problems: how to achieve an environmentally friendly method for hydrogen production while increasing its efficiency. To solve these problems, Depths Energy, JSC, plans to develop a fundamentally new technology which utilizes hydrogen sulfide as the main source for hydrogen production. Mining and processing industries produce hundreds of millions of tons as a byproduct, while there are estimated to be billions of tons in the Earth's interior. Hydrogen sulfide is a dangerous toxin that has no practical use in human activities. Therefore, it must be disposed of. Traditional methods of hydrogen sulfide processing involve separation into water and solid sulfur. This process of hydrogen sulfide separation is only possible at ultra-high temperatures reaching 1,100 to 1,300 degrees Celsius, and therefore requires high costs. In addition, hydrogen is lost in combination with oxygen in the process to form water. In February 2006, Russian scientists discovered a new hydrogen sulfide decomposition reaction. We have developed the concept of a fundamental role of catalysts in the process of hydrogen sulfide low-temperature decomposition, which is based on the principles of non-equilibrium thermodynamics of irreversible processes. This is a new scientific discipline that was created in the mid-20th century and forms the basis of hydrogen sulfide low-temperature decomposition, which occurs at ambient temperature and pressure with hydrogen sulfide conversion close to 100%. Hydrogen produced through this process is able to compete with traditional energy sources. The largest reservoir of hydrogen sulfide in the world is in the Black Sea Basin. Hydrogen sulfide, dissolved in water, is found in the bottom waters at depths starting from 200 meters, and its volume is growing from year to year. Starting at a depth of about 200 meters, the Black Sea waters do not contain oxygen, but rather many different reduced forms of sulfur known under the common term hydrogen sulfide. Hydrogen sulfide is an excellent energy resource, but is also a hazardous substance for regular existing ecosystems. Accordingly, the first task is to protect the Black Sea ecosystem. The second task is to use the energy resources of this sea, primarily hydrogen sulfide, for energy. Hydrogen sulfide from the Black Sea is characterized by the fact that it is a renewable resource and is renewed at a rate of several million tons per year. The Black Sea hydrogen sulfide reserves are estimated at 4.6 billion tons, which is a potential source of 270 million tons of hydrogen. The annual growth due to the decomposition of remains, bacterial activity, anthropogenic effects, and tectonic processes is at least 4 to 9 million tons. Depths Energy, JSC, is going to be one of the first companies to solve the problems that hydrogen energy sector faces. For this purpose, the company plans to build an experimental facility in the sea for research and development on the process in real environment conditions. We are creating an innovative scientific and technical center where highly qualified professionals will work. It will be fitted with unique ultra-modern equipment. Our goal is to create full-cycle industrial technology for the most environmentally friendly processing of hydrogen sulfide into hydrogen. Following these work results, mining and processing platforms will be constructed in the Black Sea to supply hydrogen and sulfur to the shore. By 2050, the company plans to create a fleet of hydrogen production platforms. Such a scale would not only affect the entire industry in general, but would also propel Depths Energy to the top of the entire energy sector. This project is of federal importance for Russia. Our country has a long coastline along the Black Sea. In the long term, increased concentrations of hydrogen sulfide in the water can negatively impact the sea's environment, which will lead not only to the deterioration of the region's tourist attractiveness, but will also result in a real environmental disaster. It is impossible to clean the Black Sea using currently known methods. In the course of creating the Depths Energy project, we treated the future as if it were already here. Today, the idea of our project is the best innovative product in the area of environmental energy ideas. Our highly professional team brings together scientists, engineers, ecologists, and managers. In the course of developing and implementing the Blue Ocean Strategy, we have reached the stage where investments made in the required infrastructure and production will yield steadily growing income that is unlimited over time. We are pioneers who have taken on a global mission. Our proposed method of processing a poison, hydrogen sulfide, that is destructive for all living creatures will not only beneficially affect the conservation of the living waters of the Black Sea, but will also make it possible to produce pure marketable hydrogen, which is the main component of a new era of clean energy. For world powers, green energy has gradually become the main economic alternative. In June 2019, China introduced the first hydrogen-fueled passenger car, Grove Obsidian, and a few years earlier, the American company Nikola Motor demonstrated its first hydrogen-powered truck. In Europe and the US, dozens of hydrogen filling stations are already operating. Leading automakers have joined in by investing in their construction. As soon as hydrogen fuel can cover all costs of extraction and production, the demand for hydrogen energy will increase en masse around the world. We are not dealing with a forecast, but with the inevitable future. By the end of the century, we will be faced with 3 development scenarios, 2 of which pose enormous challenges to humankind, while the third one predicts the almost complete extinction of the population. Humanity still has time. Time to make the right choice. Time to unite. Time to put hydrogen energy at the forefront of progress.